Hey everybody, we just dealt with our parent functions. So now we're going to be dealing with our transformations, dealing with all those parent functions we just completed. So that deals with the greatest integer function, that deals with the rational function, absolute value, quadratic, everything linear, constant, every function that we just talked about with the parent functions is going to be transformed using these rules that we're getting ready to talk about. So first off, let's go ahead and move on to this first part. So I'm giving you guys a general, just again, general rule for, or general formula for transformations. So this actually is like, hey, f of x equals a, parentheses x plus b, close parentheses plus c. Now with that, that can work for any type of transformation, any type of thing, any type of function that we're going to be dealing with. So it could be quadratic with the square. It could be cubic. It could be the absolute value. It could be the step function. Oh, sorry. It could be any of these here. And with that, as we're talking about and going through these, the transformations are going to work for each one of these. The C is going to have a transformation. Your B is going to have one. Your A is going to have a transformation. And whatever's in front of A, if it's a negative, it's going to transition it to do something or translate it. All of it's going to do something. And it doesn't matter which function you're dealing with because the A, the B, and the C are going to do the exact same things. So with that, let's go ahead and start off with C. We're going to start off with our back letter back here, back number. And then we're going to move forward through this whole thing. So we're going to do C, B, then A. All right. So, oops, let me cover that up for you guys. Here. Again, we'll put the general formula up at the top again. So that way we can say, okay, well, again, this works for any function no matter what's going on, no matter what. So here we're going to do the A, again, parentheses x plus b, parentheses plus c. We're going to do that again. But we're going to talk about that C. Now, the C on the back is going to either move the function up, like every single point on that function up, with the plus c, with the positive, or it's going to move every single function, a part of that function down, which would be negative c. So it's either going to move everything up or move everything down. And it's all depending on what kind of c it is. All right, so with that, we're going to take a look at our step function here. So for example 1, it says use the parent graph, the step function, the greatest integer function, and we're going to sketch the graph of each function. And then this is going to be the same instructions for pretty much every single one of these problems that we're going to deal with when it comes to transformations. So here we're going to do f of x equals the greatest integer function of x minus 4. Again, because we're dealing with a plus c on the back of it, that means here that's the plus c, or that's the c itself. That's c. And since it's a negative c, that means we're going to move it down 4. It's going to go down, and it goes down 4, because that's the number 4. So with this, we're going to go ahead and graph out the parent function first. So we have our wonderful graph here. And so with that, if you need to pause the video and actually go ahead and write the graph down or create the graph, and then press play to go through it, go ahead and do that really quick. But I'm going to keep moving on. So press stop. And then when you get everything ready to go, press play, and then we're going to come back here. All right, so with that, we're going to go ahead and graph out the parent function. And I'm going to put this in blue. And again, this is the step function, the greatest integer function that we just talked about. So here, so all we're doing again is we're doing the step function, or greatest integer function. And remember, it goes on forever and ever and ever. So I just stopped at 4 because I can't go any further on my graph. But it goes on forever and ever. And I want to make these big enough so that everybody could see it. And again, with this bottom part down here, because my graph is cutting off right here, I'm stopping. But again, it goes on forever in both directions, positive and negative. Remember, we said that the domain here is negative infinity to positive infinity. So it goes on forever. So with that, that's what has to happen. Just go on forever. All right. So with this, though, when we talk about our transformations and what's happening here, we said, okay, we have our parent function, which is the blue part, and we're going to move everything down 4, because that's what our transformation is set to do. We're going to move everything down. So here, we're going to look at this part first. We're going to take it down from here. We're going to go 1, 2, 3, 4, and move it down. Oh, Jesus. Take this one, we're going to move it down 4. So 1, 2, 3, 4. Again here, take it down. 1, 2, 3, 4. And then so on and so forth. Everything moves down 4. Now with this one, because it's a step function, it's going to be over and over and over again, a tedious process. So as long as you do the first 4, 3 or 4, I like 4 better. I didn't do this one, sorry. That's 1, 2, 3, 4. Now the next one here is going to be like off my graph, so I'm not going to do that one. But this is what I'm looking for. Just that you show that you had the parent graph, and then every one of these move down 4. Just down 4 spots. And if you do like at least 4 of these for the step function, you're good. And that is your vertical transformation there. They're moving it up, moving it down, and that's it.